Hello, everyone. Hello. I hope I'm live and audio's working and everything. I'm Cindy Drozda, and I'm here to talk about uh, hollowing systems. And it's great to see everyone here. We've got a bunch of my good friends here. Chris from the UK and David Perez. Good to see you here. This looks like Todd and/or Shelley. Glenn, great to see you. And Mux Woodworks, whoever you are, thank you for the confirmation about the audio. Paul, good to see you. David, always good to see you here. And I am here in my studio. I'm trying some new stuff today, so let's get started with things. The first thing I want to do is go over some uh, upcoming events and things. And Lee, yeah, the bike trip was fabulous. We did like 280 miles in 5 or 6 days out in Western Colorado. And we didn't all ride all the time because we had a chase van to drive. But anyway, it was loads of fun, great weather, great scenery. I really enjoyed myself a lot and I got a bunch of exercise and I always like that. So yeah, so I'm going to get started with showing some stuff that's coming up. And that's not where I wanted to be, actually. We'll go here and start at the beginning. I am here in Erie, Colorado, a great place to be, Colorado. And you can see where I am in relation to most of the world. It's getting to be winter time here. It's raining today, which is great for us. Might turn to snow later. But yeah, we're building fires now. And what's happening in wood turning? Yes, that's what I'm all about. What's happening in wood turning? Next up is my IRD, which is happening on this coming Saturday. And here's there it is. It's a hollow vessel with a collar, Saturday, October 29th. It's at 1 p.m. Eastern, and you can sign up on my website. And let's see about oh, that didn't do it. Here is something new that I've got going on, and you can scan that code with your phone right on the screen, and you'll get to my subscribe page, uh, which will get you signed up for my newsletter so that you'll hear about all my upcoming events. And actually, let's see about huh. I'm trying to get up the actual code that I wanted to show you, which is this one. If you scan this code, it takes you to a page on my website where you can sign up for my demo this Saturday for 10% off. So that's always fun. And try that QR code. I want to see how it works. Okay, well, looks like Todd tried it. Cool, very cool. Yeah, good to see you, Mike. Charlie, England, east of England. All right. Oh, and good. We've got several countries represented here. James, good to see you. Yeah, so that's an event coming up, my next IRD, and what I'm going to be doing is making a lidded hollow vessel and with a collar, and it looks like that QR code thing is a little bit unfortunately blocking off everything. So let's try this for the QR codes. Is that the one? No, this is the one. Yeah, so there's the QR code. Try it there and see if that works, because then it doesn't block my graphics here. Yeah, so that's this Saturday, and then coming up uh, after that will be the follow-up session for this Saturday's session. But I want to give you a little explanation of my lidded container series. Oh, and look at Sony's supposedly excellent autofocus, not so excellent all the time. I might have to fix that one too. Uh, I've done 4 sessions, and this is number 4 coming up on lidded containers, and starting with the waterfall, and then the lidded chalice, and this Saturday is going to be this one here, the lidded hollow vessel. I am going to need to take a little second and get off of autofocus. Okay, I'll be right back. Autofocus is a good thing when it works, but I am actually not a fan of autofocus. And there we are on manual focus again, which usually comes out looking okay for where I am. All right, now at least it won't change. My face getting blurry like that. All right, so what I did was the session number 2 was the finials and pedestals for all 3 of these containers. And I will be doing a finial actually this Saturday because this is a slightly different style of finial, uh, being that it's a one-piece lid and finial, unlike the one I did on the other vessels. Okay, so Lyle Jamieson, my good friend, is doing a 2-part, or has been doing a 2-part IRD on his hollow form of the natural edge. And he did part 1. Here's where you can sign up for him. I don't have a QR code for Lyle. He did part 1 last Tuesday, a couple days ago, and that was really great. He did a lot of stuff about design and using the burl and how he was going to oriented on the lathe and stuff, things I have done before also in some of my sessions. But I encourage you to check out his next Tuesday, part 2, which will be where he does the hollowing and sanding and finishing, and that'll be good fun. Lyle always does a great job, and we have a good time with him. And my good friend Todd, he does live streams alternating weeks from me. His slot is Thursday on or Friday at 2:30 Central. And my slot is Thursday at, well, it'll be 1 Central, or noon Mountain, or 2 Eastern, or yeah, I'll get to mine in a minute. But Todd does Fridays, and he'll be doing one this coming Friday. I mean, next Friday, because I have this week. Yeah. And so I encourage you to check out Todd's live streams. Live streams are fun. They're kind of spontaneous. You can see it's a little bit less programmed than perhaps could be, but that's part of the fun, really. And Lyle is here. Yay. And Todd put up his um, a, a link to his demo in the comments, so that'll be good. You can see those. Now, I'm not sure if I'm getting comments from Facebook. It's possible that I'm not, and if I don't see them here live, I'll go back through my Facebook profile and answer the questions you might have. If you do have a question, please, yes, uh, put it in the comments, and I will get to as much as I can on questions. So Todd's doing this live stream, but he is also doing, my technology is, there we are. He's also doing a demo on November 16th, which is a Wednesday, on turning a pair of candlesticks. And you can see his link there, woodturningtoolstore.com. I don't have a QR code for that, so this will have to do. And then, yes, my live stream. And to get notified about my live stream, go to my YouTube and sign up for notifications, or go to my Facebook page and click the I'm going send notifications button, and you'll get notified. You can also, um, where am I? You can also scan the QR code and get to my sign up page, sign up for my mailing list, which will get you to uh, where if I get around to it, and I usually try to, I will send you out a notification when I'm doing the live stream. It's every 2 weeks on Thursday. Yeah. And so, yeah, I'll leave that up for just a second there. And if you subscribe to my list, you get notifications for all kinds of things, including here's something fun coming up next, vendor showcase. We're doing our holiday vendor showcase on December 10th and 11th. And let me get that up here. If I have it, do I have it? No, I don't actually have a ticker for that one, but I do have. I'm supposed to have a QR code. Yes. So now you can scan this QR code and get to the registration page for Vendor Showcase, newly updated with a very nice logo on there on the registration page. And I'm having fun with these QR codes. Try them out and see what's going on. Oh, and yes, Facebook. Very good. Thank you, Todd. Steven says he's on Facebook also, but it's showing a little YouTube logo for you. So I don't know what's going on there. Scott, always great to see you. And you've got some upcoming demos also, I know. And hopefully I can make it to see what you're up to there. And Vendor Showcase in December is the furthest out of scheduled events that I know about. I just want to let you know what we're all doing here. Okay, the chat function on my Facebook stream is locked. Yeah, I don't know. Facebook has changed some stuff recently. What they changed was that they did this thing where they decided that they were gonna okay, there we are. That they were gonna make every live stream into a quote unquote event, which has different parameters and different rules and displays differently, and I'm still trying to figure out. So, yeah, I'm going to address that as soon as I can, Paul, about that Facebook weirdness with the chat. So, yeah, bummer about that, and I apologize. And like I said, if you type me a question in the chat, I'll get to it as soon as I get done here, because I can't really chat and talk at the same time. Anytime I try it, I fail miserably. Okay, so today's subject is hollowing, but I'm not going to actually do any hollowing. My goal here is to talk to you about some of the what's going on with different hollowing systems. All kinds of hollowing systems, and you're probably wondering which one should you choose and why. And you know, that's a it's a good question, especially the why part and what's going on with them. And there are different levels of things. So I'm going to go through a little bit about what goes on with hollowing. All hollowing systems consist of three components: cutters, bars, and handles. And now, before I get too far along, what I'm talking about when I say hollowing is I'm talking about where I might be going to take a vessel like this one with a relatively small opening. I think the definition of hollow form is that the opening is 1/3 or less of the total diameter of the piece. So this is a hollow vessel. And in order to reach around the corner to hollow out a shape like this, a person's got to have tools that'll reach in there. You can't just do it with your bowl gouge or, well, certain shapes you can do with your spindle gouge, but typically we have hollowing systems that we use. So to start with talking about the systems, here are some examples of cutters. And the flat high-speed steel cutter, that's a teardrop cutter, which I get from the Woodturning Tool store, by the way. Uh, it This is for finishing cuts. It's not really a material remover. The carbide cup cutter is a good material remover. Doesn't need sharpening. Lasts a really long time. They can either scrape or cut. They're kind of fiddly to set up if you expect not to just be scraping with them. And I'll show a little bit about how I would mount one of those. The square high-speed steel cutters, these are 3/16, about 4 or 5 millimeters square. And this is the pretty much most typical hollowing system cutter that you'll find. And a lot of systems use these. So bars. The bar is the thing that holds the cutter. And there are so many different ones. These are the ones I have, and you can see some are 3/4 in diameter, 19 millimeters. Some are half inch, 13 millimeters. Some are 3/8, 10 millimeter. And the reason I would choose one shape over the other is the size of the opening and the shape of the vessel. All those different shapes are designed to reach in around different shapes of vessel. And sometimes you'll find hollowing bars and cutters sold together as a set of, this is John Jordan's set, and he's given you a couple of different shapes that will do a wide variety of vessels, and they come with a cutter in them. And to talk a little bit about how the cutters mount on the bars, and please, if you have a question about hollowing stuff, or you want to make a comment, talk to me. Type a question in the chat about what you're up to and what you think about hollowing. And I'm going to kind of run through from basic to more advanced and why we might choose one type of system over another. So, this is interesting. So Duncan is managing to comment on Facebook. And I believe Todd also commented on Facebook. So I don't get it, StreamYard, what's happening here, or Facebook. It's probably Facebook's fault. I will try to get that sorted later. Okay, so we have cutters and we have bars so far. The cutter mounts on the bar, and you can see at the top left, that is the swivel assembly with the high-speed steel square cutter. And this is one that I use extensively on different bars, depending on the vessel size and the size of the opening. And I even have a miniature swivel assembly that I have made for very small vessels, or not so much small vessels, vessels with smaller openings, because the bottom line of it is, can you fit that apparatus through the hole, right? So that's a swivel assembly that Lyle Jamieson uses and supplies with his system. I'm going to show that one in a little while. This carbide cup that's on the square insert is one that goes into that swivel assembly on a system like Lyle Jamieson's to make it a carbide cutter instead of a high-speed steel one. And I'm not going to go into the really picky specifics about how to use that one, but if you go to Lyle Jamieson's website, you can find a lot more information about that. And I think we had his website put into the comments earlier, but he's got lots of information on how he does that. So another way people use these carbide cups is in the lower left there, you see a set of hollowing tools. And these are the Trent Bosch hollowers here, just FYI. Another very good brand of hollowing tools made in the US. He's got the the carbide cutters mounted on those shapes of bar. The Jamieson system with the carbide on the square insert uses the swivel assembly on the end of whatever bar, really. I use it on different ones. So these are different ways to mount a cutter on a bar. In the bottom right, John Jordan's method is to take the high-speed steel square cutter, and if you look at the last slide here, you can see that one of them's rounded over on its end so that it'll fit into the hole in the end of the tool. And some of his have got a bigger hole, depends on what size bar it is. And that is also chosen because of what size opening and or shape of vessel I might be wanting to do. Sharpening these 3/16 square cutters. Some people will put them in little holders on the grinder. I just put them on a platform and do it holding it with my fingers. I've had really good luck with that, but lots of different ways to sharpen them as well. So if you're looking on somebody's website who sells hollowing stuff, then you'll see a lot of options. That was my point there. Okay, so the bars go in handles and some kind of a handle. This is the simplest, most straightforward hollowing system to start with. And it consists of a cutter on the end of a bar in a handle. And it's just a straight handle with set screws. And here we are with this kind of a thing. I've got my hollowing tool, cutter on the bar, and it's just in a straight handle, and I would use this with one hand on the tool rest and the other hand at the end of the handle. And this is the actually simplest and cheapest way to have a hollowing system. So the carbide cup tends to be aggressive because it's got quite a sharp, aggressive cutting angle, but you can adjust its presentation to the wood to make it less aggressive. And if a person is doing hollowing like I just showed there, which I call that handheld hollowing, as opposed to captured hollowing. Do I prefer handheld or, okay, jig held? That's another way to put it. I'm going to call it captured. But yeah, I will get to that. I'm going to explain. I'm glad you asked this question, Duncan, because I am going to go in depth into the why, because there's physics going on here, or mechanics, or whatever you want to call it. And I started with handheld hollowing, but as soon as I found a better way, I went there. So I'm going to get on with that. Now, so the next type of handle, kind of a step up, is the arm brace handle. This is John Jordan's modern version of the arm brace. Here is the arm brace handle that I learned with. It's the Dennis Stewart system. And you can see what's going on here is my elbow is in this, it's kind of a cradle that my arm goes in. And then the other thing is my wrist is upright so that I have a better wrist action for resisting the rolling of the tool. And I've got 2 points of contact with this arm, put it on the tool rest, and I can also use this other arm. This is kind of an awkward position. I would actually be further away. And a lot of people like to use this sort of system with their headstock moved all the way to the end of the lathe so that they're standing right in front of it instead of leaning over like I am right now. So this is another form of basically handheld hollowing. And when this kind of a system came out, and I guess it was probably the 90s or something, this was a big step up from the plain straight handle handheld hollowing. And that's how I learned to do hollowing and how I did it for quite a while. But actually, I really believe that there's a better way. And the better way is the jig held, or I usually call it captured hollowing, because the handle is an apparatus of some kind or another. I'll show a couple more that captures the handle in some way. This is the Advanced Lathe Tools system by Steve Sinner. It's showing up first here because he had a beautiful picture I could grab off his website. It's not because it's a necessarily better system. It's an excellent system. He makes really high quality stuff. As you can see with this one, we have our cutter on the end of our bar, and that's resting on the tool rest. And then we have a handle, and there's also a laser measuring device, which is another subject altogether. And the handle is in a window, capturing it to counteract the forces from hollowing. This system has a double 3/4 inch bar. That's 19 millimeters each bar. So it's about 1.5 inches, about 40 millimeters wide in that window there. Here's another example of captured hollowing. This is the Jamieson system, and it's the same idea. We don't see the tool rest here, but at the business end of the bar, it would be resting on the tool rest. You can see that swivel assembly cutter installed in there. This gives you a good view of the laser. It's a device that is holding a laser pointer directly over the cutter, and that's used to measure wall thickness. And you can see that the Jamieson handle is wider. It's about 8 inches wide. I call that a D handle. It's kind of D shaped there in that window opening there. So that's how it's captured. This one, you can see the base of it. It is attached to the lathe bed. At least that's one option. This one here, you can see that it's in basically the banjo. Well, I think in this picture we have the tool rest on a separate base, and the banjo or tool rest base that comes with your lathe is holding the capture window. Well, I ordered another banjo for my lathe, so I have the tool rest in a banjo and I have the hollowing window in a banjo, and that's how I like to do it. So seems far from the vessel. Yes, but you are not standing at the back end of it. You are standing right near the vessel and controlling it. You're actually standing closer to the vessel than you would be if you were doing handheld hollowing, where you've got that long handle. I'm going to talk about why you need a long handle here in a minute too. So my point here is there's a way that the window attaches to the bed of the lathe so that it can be somewhat movable. This one uses the tool rest base, which allows you to move the window in the base. It's usually at a fixed height, but you want to be able to pivot it, and you want to be able to move it back and forth on the lathe bed, and that's why it's in a tool rest base banjo here. This one has a base with a knob that fixes it to the waves the same way the banjo would, and that allows you to pivot it around. And then there's also a pivot adjustment and a height adjustment on the vertical post. Could this be set up on a shopsmith lathe? I doubt it, but somebody might come up with a way to do this, and I'll show a couple other systems that might lend themselves better to a shopsmith lathe. I'm going to go kind of out on a limb here and say that the shopsmith was not meant as a lathe to handle the kind of forces we're putting into a piece of wood when we do this kind of aggressive turning, unless you were maybe doing little ornaments or something. So I don't know what to say here. I'm not going to recommend using a Shopsmith for captured hollowing, but let me know how it works. Okay. I can be opinionated and closed-minded, and I hate that, but it comes out quite often. Okay, so here we have just shown the captured system that has a separate rest with a window capturing one end of the handle. The other end of the handle's on the tool rest. And here's something else. Okay, so Duncan's got some hollowing tool suppliers in the UK, and I'm kind of going over some basic principles of hollowing here, styles of system, but yeah, there are dozens or hundreds of different companies that sell systems that are operating on most of these principles that I am putting forth here. This is not an ad for a particular system, although, of course, I'm going to show you the one I own because I can't afford to just buy every hollowing system in the world so that I can show it off, right? So, yeah, look at Simon Hope Woodturning in the UK, and they've got a bunch of stuff. I think there are other UK suppliers as well. Lyle's kind of in agreement with me here, and it's mainly because the Shopsmith was just really not built for that kind of force. As a I had one for a lot of years, 50 years maybe, almost. I just sold it a few years ago, and my opinion of the Shopsmith was it's a really good drill press. It's an excellent horizontal boring machine if you need one. It's a kind of okay miniature table saw. It's a great disc sander. It's a terrible lathe. I would not recommend buying a Shopsmith to somebody who's looking for a lathe. But lots of people do turn on them and have some fun. And I would recommend it more for spindle turning than for what we call faceplate or chuck turning. All right, so to carry on with this, and I love your questions, by the way, and comments, so please keep them coming. I want to hear your thoughts about stuff. And yeah, good point, Duncan, about other countries and where to buy stuff. I'm not going to get into where to buy stuff here, really. I'm just going to talk about it's mostly the mechanics, the physics. So, what else have we got? Okay, now here's another way to do a captured hollowing rig. And there are several of this style out there and I've used one of them. It was made by Vicmark years ago, and it's more like the next picture I'm going to show than this one. This is Trent Bosch's system. It all goes in one tool rest post, which is genius in a way because you've only got the one apparatus. You don't have to have a second banjo or any of that stuff. And this is what I'm going to call a cantilevered type of hollowing system. It's captured, yes, because the handle is captured. It can't go anywhere except for around the surface of the vessel. It can't, I'm going to talk about the forces here in a minute, but it can't be pitched or rolled like handheld hollowing can. So Scott's a Shopsmith know-it-all, yes, and agreeing with me that they were really made for turning spindle projects like cabinet parts and legs and things. And yeah, it does not have really substantial spindle bearings. It's not really designed like our modern lathes to handle something that is only held on one end. You're on the same page as me there. Well, okay, Duncan, you're going to have to address that one. If Simon Hope doesn't ship to U.S. or Canada, okay, and maybe he ships to Italy. Hello, Pietro. Good to see you here. Okay, articulating is a way to describe this kind of system. It's an articulating arm with several joints in it that allows you to move the handle to get around the shape of your vessel. This kind of handle will take your assortment of choice of bars and cutters. This is just a description of a handle. Now, everyone who sells handles always sells cutters and bars as well, but I don't like to be limited there. I will use anybody else's bars on anybody else's handles and anybody else's cutters just to get what I want to do. Okay, so maybe it depends on, you might have to call Hope if you want it in Canada. And here's Alan Z. Articulated arm rigs, yes. And we all are great minds. Alan is the guy who taught me how to use all this technology for the online demos and things. And so big thank you to Alan for getting me going, and many other people. He's taught most of the people who do this stuff. So here we are with an articulating rig that has one holding point, right? Here we are with an articulating rig that has two holding points. You don't see the tool rest in this picture, but the business end of the bar where the cutter is would be resting on the tool rest. So this has got 2 points of support. That backrest there, where the articulated arm is, anchors to the lathe bed. You could also put this articulating arm in an extra banjo if you liked that option better. That's what I would do because I do like that option better. But this is how it's sold. And this is the elbow rig. Now, elbow's been around a long time. And when they first came out with their thing, they had their articulating arm in the tailstock Morse taper, which it's genius in a way because you don't have to you don't have to have a base for it. But they have, I guess it probably doesn't give you as much flexibility in the shapes you can turn because it's just fixed in that one place where the tailstock is. So, okay, so that's another way to do articulated arms. And I'm going to go out on a limb here about mechanical design here. Now, if I have this system and I have the tool rest resting, or the tool resting on the tool rest, but then the rest of the arm is cantilevered off of that point and is not directly supported beneath its attachment point to the tool, whereas this one is. I'm going to say that this is likely to be stiffer and more stable, less likely to chatter, particularly if you get into a larger or deeper form. Now, a word about articulated arm systems. They tend to be really easy to use, fast to set up, don't take up as much space, maybe. But the downside is they tend to have less range of motion than, let's say, the window type captured hollowing rigs. So they're really good for a narrow range of shapes, but they're not great for a huge range of shapes, particularly not good for very large pieces with this shape because they just don't have the reach from edge to center. Like if this piece was way bigger than it is. So that has been my finding about some of the different rigs. Harrison's simple hollowing system. It's one I haven't heard of, but this just validates my point that there are a million different hollowing rigs. A lot of them are really quite good. I think most of them operate on the principles I'm laying out here for you, that they are consisting of cutters, bars, and handles, and they are either handheld in some form or another, or they are captured in some form or another, usually either a window, an outrigger, or an articulated arm. So, hello, Carolyn. Let's see. Thank you for this video. And you're very welcome, Carolyn. Now we're going to move on and talk a little bit more about the forces in hollowing. So I'm first going to describe the main two forces on our tool when we're hollowing. And I'll do it with the handheld rig here. I'm going to show this with the handheld rig. We've got pitch, which is when the wood comes around, it's putting pressure down on the tool. As the wood's spinning around, it comes down onto the tool. And one of the motions we get is, I'm calling it pitch. It tends to try to pitch your end of the tool up. The arm brace handle gives you where you have your whole forearm supporting, and it gives you a better bracing for those pitching moments. A handheld tool like this one, I'm not going to hold it right up here. I'm going to hold it back further so I have more mechanical advantage. More on that here in a moment. And then the other force we're contending with in hollowing is what I'm going to call roll. When the wood pushes down, it's coming down, it's going to try to roll the tool over. That's what tends to happen. So you, with your handheld rig, are counteracting the roll with your hand. And that's where that arm brace came from, where you've got your wrist upright, and that allows you a little more mechanical ability to resist that rolling tendency. Sometimes we'll use roll to our advantage, and we will roll the tool over to make it less aggressive, and then bring it back up more level to get the aggressiveness of cut that we desire at the moment. And that's a little bit of the finesse of doing handheld hollowing. Captured hollowing, either with a window or an articulated arm or an outrigger, we are not doing that because we don't need to. The roll is and the pitch are taken up by the capturing of the system in the handle. So that's a description of the forces, pitch and roll. Now, how are we going to deal with them? I'm going to show some stuff about roll first. And this is an example of, I actually own these two. This is an example of a type of turning tool that was designed to reach around the corner of the vessel. And what's going on here is, if you look at it on the tool rest, the center line of the bar that's on the tool rest, this is the point of contact. The center line of the bar there is quite a distance away from where the tool contacts the wood. More severe in the one that's 2 inches, 50 millimeters from the point of contact, than the one that's only 3/4, 19 mil from there. So counteracting this roll force is done by your handle. In a handheld hollowing rig, you're counteracting that force with your wrist, basically, or your wrist in an upright position. And I've got somebody doing bad things to me. Did we get rid of all of them? I think so. Yeah, sorry about that, folks. There are mean people in the world interfering with people like us for no reason. That's ridiculous. Arm brace handles have been known to cause shoulder injuries. I have heard this, and I haven't really heard it in exactly so many words, but what I have heard is handheld hollowing, period, puts a ton of force into your body, because whether you're using an arm brace or a single handle, you are counteracting all of those forces. Basically, they're going into your shoulders and your elbow. So this is why I use a captured system. But I'm just talking about all the forces and things. So good point, David. Yes. And You're going to have to translate this one for me. I do appreciate people coming from all over the world. This is great fun, isn't it? But sometimes I cannot understand. I understand a teeny bit of French or Spanish, but whatever language that was, nope. Hollowing is the most difficult in wood turning? No, actually, hollowing is very easy, and it really doesn't take a lot of skill or talent if you buy a system that makes it easy for you. There are always ways to do things much more difficult, make things more difficult. But what I'm leading up to here is that we have the technology to make it very easy. And to me, hollowing is, maybe you'd call it a skill, but it's not a talent. All the talent goes into making the shape of the vessel or ornament or whatever you're making, or the embellishment. But hollowing is like, who even cares? The only reason it needs to be hollow is to keep it from cracking and let it dry a little faster than if it was a great big huge solid piece of wood. So I don't give much credence to developing skill doing hollowing the hardest way possible. And probably the hardest way possible would be to have a handheld rig with a straight handle using a tool like you see here at the bottom with the 2-inch overhang, or put more overhang in it, it'd be even worse. That would be the hardest way to hollow. And I don't really see that doing something in a way that makes it harder gives you anything better at all. May as well make it easy. Ladislav in Czech. I greet you from the Czech Republic and wish you much success and happiness. And thank you, Ladislav. I wish you also much success and happiness in your life and your turning. Thanks, Todd, for that little Google Translate there. Or maybe it was a Facebook Translate. So this is a dilemma here. Roll is needing to be counteracted by something. And here are some things we do. Now, David Ellsworth is famous for developing a set of hollowing tools that look pretty much like this. He doesn't have any accounting for roll at all, except for this. The handle, if you ever look at David's hollowing tools, the handles are huge in diameter. And that grip with your hand at a greater diameter than the overhang is giving me mechanical advantage to overcome that rolling moment. So that's one thing to be done. Because you can see he's got an inch from the center line on his hand, and it's 3/4 of an inch from the center line from the cutter to the center line. So he's got a teeny bit of mechanical advantage over it. And here's another idea. This is something invented for handheld hollowing. It's an outrigger, I'm calling this. And the way it works is both the outrigger and the tool sit on the tool rest. And that arrangement then goes in a handle. You could put this in your captured hollowing system, but you wouldn't need to. You could use this with an arm brace. Most people use it with a straight handle. And so it's a little bit of a step up in control from just having a straight handle. And you can see that this tool is cantilevered out from the support point, just like the ones in the last slides, right? It's the same design as this. But what it's got going for it is that outrigger gives me a lot of mechanical advantage against the roll moments by being further away from the support point, from the tool, further away from the support point than the tool is. The outrigger is further away from the support point than the tool is, so it therefore absorbs the roll motion of your turning. And roll is probably the hardest one to control in handheld hollowing. So here's another solution to that roll problem. And this is what most commonly is seen. And these are the bars I started using. And what's going on here is the bend is formed so that I can get around the shape of the vessel, around the curve of the undercut opening of the vessel. But it's bent in such a way that the center line of support is right on the same line as the cutter's line. And that gives me the ability to have the, oh, I don't want to show that yet, to have the roll be neutral, because though the tool is trying to be rolled by the lathe, it's no worse than if I just had a straight tool with a cutter on the end of it. So this is what Dennis Stewart, I think, invented back in probably the 80s or 90s or something, and it was a revolutionary in its time. It is a little more complicated forging though, and today we have lots of people still making these: John Jordan, Trent Bosch, Mike Hunter, probably Simon Hope in the UK, and various others. So here's something to think about. If the support point is back here, then I'm cutting on the same line as the support. If I move the tool rest closer to the work, then I am supporting on the elbow of the bend, and I now have that same situation where my cutting point is cantilevered out past the support. So this design of tool needs to be used on the tool rest with the whole bend in on the headstock side of the tool rest to get the advantage that it's giving you. Now, of course, if you use a captured system, you can do whatever you want, because the captured system, I'm going to talk about why in a minute, takes care of all this for you, and you don't have to think about it. Although I usually do put the support point back on the uh, after the bend. So this kind of hollowing handle. Now, bars and cutters, of course, like I said, are interchangeable. We're just talking about what happens when you use a different kind of handle. And this kind of handle also have to counteract pitch. And here's what we need to think about. In order to be successful in controlling the pitch that's caused by the tool or the wood coming down on top of the tool, we need to have something like at least 5 times as much length from the tool rest to the end of the handle as we have from the tool rest to the cutter tip. So look at this. If you're doing a 6-inch depth of hollow vessel, you need 30 inches, 750 millimeters of handle on the tool rest side. That's why you'll see these people who have these monstrous boring bars with like 6 or 8 foot long handles. And that does accomplish what they're trying to do, which is to absorb the pitch forces very well. The more mechanical advantage you have over the amount of tool rest overhang, the easier your pitch control will be. But, what was I going to talk about here? So this is if it's a miniature one. 2 inches or 50 mil of overhang, all I need is 10 inches of handle to get that same 5-to-1. So we're talking about the difference here between a deeper vessel and a shallower one. So I'm going to use a longer handle if I plan on more tool rest overhang. Go ahead and calculate and see what happens when you've got a 12-inch depth. That'd be 300 millimeters depth hanging over the tool rest like a tall vessel. That's where you need a 6-foot handle. The articulated, or let's say the captured systems, take care of pitch control really well because it's set. There's no way that the forces from the wood into the tool can move that arm. And this one, if there's any slop in that linkage, that'll pitch around a little bit. but generally they're really tight and well made. This is a Trent Bosch one, and he makes really good stuff. The elbow, you know, again, it's going to, if there's any slop in those linkages, it's going to be, it's going to pitch around a little bit, but it's not going to be overcome by the pitch of the lathe. It's controlled, and these kind of systems, all of the captured systems, make hollowing super easy. You don't, and here's how I like to think about it. When I was doing handheld hollowing, I was using 95% of my brain and muscle power just keeping the tool in control so that I could hollow out the shape I wanted. With the handheld system, I'm using 5% of my brain and my muscle controlling the tool. I can even kind of get up and walk away from it if I want to, because the captured system holds the tool right there. So that frees me up. Instead of 5% of my brain concentrating on the shape and the job I'm doing, 95% of my brain is concentrating on doing a good job. And I'm also not beating up my shoulders and my elbows and my wrists. So I'm sold on it. The first I saw a captured system, I said, this is it. I'm not going back to handheld hollowing. What's the advantage of handheld hollowing? Why would anyone even do it? Well, it's cheaper. I think that's probably going to be everybody's answer who does handheld hollowing. There's another reason why people do handheld hollowing. Take John Jordan, for example. He learned how to do it like 40 years ago, and he's really, really good now. And you can, there's a little bit less setup, and you don't have a big apparatus to store in your shop. So some people will say, yeah, I can just pick up my handheld hollowing rig and I can get the job done really fast. And those are usually people with a lot of experience at it. If you don't have a lot of experience at hollowing, I would not recommend starting with handheld hollowing unless you need to save money. So let's talk now about how we're counteracting forces with the window style. The cantilevered or articulated arm and the window type both do a great job of counteracting both pitch and roll because the back end of the tool basically can't move. The window type, because there's so much length of movement in the window compared to how much movement you have with the articulated systems, you can even put a longer window on if you want. David had some 3-foot wide one made for his huge lathe when he was doing giant hollow forms. And you can move the window around and you get a more flexibility of shape. Another thing going on here, and this is just me thinking about the physics of this whole thing. The advanced lathe tools here has got 1.5 inches wide, which would be 75 millimeters. No, about 40 millimeters wide of spacing between the two contact points in the window. It's a little bit like that outrigger, and it's also like that tool that's cantilevered and didn't have the question mark shaped bend in it. The distance between those two supports are what give you mechanical advantage over the roll. Pitch, they're all pretty equal. And yeah, there's some slop in the fit of the window to the bar, which gives you some rattling around. You know, I was saying how these articulated ones have a little slop in the mechanism and it gives you some rattling. Well, you get rattling on these too, but it can't really go anywhere. The difference between, say, this one and this one is now we're looking at about 8 inches of spacing between the two contact points in the window. This is going to give me a huge amount more mechanical advantage over the roll of the tool. The roll forces into the tool. So I'm kind of getting up on my allotted hour of time here. Please do ask your questions. I see it's been pretty quiet there in the chat. I hope I'm not missing anything. But now what I'd like to do is put my actual hollowing rig up here and show you a little bit about how I'm going to set it up, the component parts, and what I'm going to do. So let's go for this view here. You can see my window there. I think I will give you a little bit better view here. So here's my window. I'm actually going to move it forward. Let me get my monitor out of the way. And bring up my hollowing apparatus. And I find this to be not too bad to carry around. I lift it by its balance point, the post for the laser, and I just set it down somewhere in the shop. I keep this, because I have a robust, I keep this window on its second banjo on the tilt-away mechanism that my lathe has. So here's an important point here. This pin is in a hole in the end of the D handle, and I need to put the pin in after I put the D handle through the window so that I can't accidentally pull this out while I'm hollowing. That would be not very good. So this is, oh, maybe I needed I needed the camera back where it was to begin with, didn't I? I shouldn't have moved it. Spoke too soon. So now you can see the whole system there. And question, do I use a laser or a camera arm with my captive rig, and which do I prefer? Yes, I was going to get to that momentarily, but I will talk about that. I'll just answer your question. I prefer the camera for the most part, and I have both. Does a flat bar make a big difference? A flat bar, I'm thinking your question is, if you had instead of a round bar, if you had a flat bar, it would give you some mechanical advantage over the rolling moments by its width. And it's only going to help you if it is wider, if the thickness of the width of the bar is greater than the distance between the far edge of the bar and the cutter. So it doesn't help much, but it helps about as much as putting a giant handle on the tool does. And you don't have a hollowing system. It's kind of like saying, I want to make bowls, but I don't have a gouge. Yeah, you can use your scrapers to make a bowl. You can use various things to do hollowing versus buying a system if you don't want to. I'm talking about what's out there. And ultimately, we woodturners, if we want to do something the easiest, most forgiving, and highest performance way possible, might have to actually buy something. But we can also make our own stuff. We can buy used stuff. There are lots of ways to save money. And to answer your question, Chris, using a flat bar does not make a big difference. It might make a tiny bit of difference, but keep in mind those forces. Oh, thank you very much. I'm explaining things well, so there are no questions. And this is a very, very good question. Is it heavy? This system, well, you saw me, and I'm an old lady. I'm not really so strong. I can lift that up and carry it around. It's not particularly heavy. One of the reasons I don't use the advanced lathe tools as much is because his stuff is really heavy, and especially the big boring bar for larger vessels. I don't really want to carry 40-pound piece of metal around. So so as the different things go, this particular design is doing it with mechanics, not with weight. The the advanced lathe tools that I said was heavy, that's the one that has a narrow spacing in the window. And it's compensating, it's overcoming the forces with weight instead of with physics. And this system, this style of system, and there are tons of copies out there that use the same principles. They tend to do it with mechanics rather than weight, although weight does make a difference. And if I wouldn't have thought it, but and maybe it's not weight, but bulk. If I put, this is a 3/4 inch, 19 millimeter bar. If I put his 1.25 inch bar, I'd be like 30 millimeters, 33 or something. The straight bar, oh, makes a big difference. So deep in a tall vessel, I'll put the larger diameter bar on there for the bottom of the vessel. Whereas I might use this one because this one has this bend in it. So I might use this one for the opening, and this is not a good example because this kind of vessel, I'm going to use this cutter for the whole thing. A deep vessel, I might find that I can, I need perhaps some compensation for the tool rest overhang with some added weight. So Lyle, who makes this system, is saying the balance is important to tool control. Ah, okay. Good point there. And Carolyn, thank you for being here. Yeah. So you must be in Europe or someplace, and it is, in fact, late out there. I apologize. I wish I could come up with a session time that worked for everybody in the whole world. It doesn't work that way, though. So I do my best. This is something that works for me, too. Yep, physics. That's what we're talking about here. I didn't take physics in high school, but you know what? Had they offered wood turning in high school, I would have loved math, physics, metallurgy. They're missing out by trying to get kids to just memorize a bunch of stuff that means nothing to them, whereas practical application would make it all wonderful stuff. So I've come about this later in life. All right, so I want to talk a little bit about the component parts and how I'm setting them up for a system like this one. And this is principles of setting up a captured system, articulated or window type. It has no relevance really to handheld hollowing. So let's get a better view. This view, I think we're going to go with this view here for now. And I don't really get a great look at this view, but this is something fairly good. So here's one thing I'm thinking about. First of all, my tool needs to be on the tool rest. Well, I think I still do this. I have it on the tool rest back behind the bend. So I'm going to move my tool rest back enough to where I can get in the opening there. And then I want my backrest window to have enough sticking out of it here to give me the depth inside my vessel. And I might actually change that as I get deeper into a vessel. But I would also like the most amount of distance between tool rest and backrest that as I can get, because that'll give even this system benefits from mechanical advantage. So I would like to have this window moved back more, and I might just do that, because this vessel is real short. So we'll move the backrest to a good place for now. And the other thing I want to do is, I don't know if you can see it, but I want the cutter to be relatively level with the back of the rig. And I want that when the cutter is on the center line. So let's first get the cutter on something that looks like the center line. That's going to give me, when I have the tool inside in the bottom of the vessel, when I'm doing the very bottom, that's going to give me a clean bottom to have the tool right on center line. So now I want to look at it and see if the backrest is giving me, and I could put a level on here. What I tend to do, and don't look at this bar because that doesn't, it's distorted looking in the picture. What I like to do is have the cutter on center line and the backrest up just a bit from level, so that I know I never have it with the cutter higher than the backrest. That gives me the wrong presentation angle for the tool when it's cutting. Not that it wouldn't cut, not that it would be dangerous, it just is not going to perform its best. So I'm going to step back and take a look here, and this looks pretty good. And then what I've got is this. I have to navigate a little bit here. Navigate down here. There's a collar on the shaft of the window that I set to the height that I want my window to be. So now whenever I put the window in, it's at the height that's right for this bar and handle and everything. When I put the larger diameter bar on, I'm going to have to raise this up a little because it raises it up with the larger diameter bar. I might just give myself a little more raise up here. It really never hurts to have the tool a little nose down. Okay, so then the other thing that I'm going to do, I'm moving the tool rest just so that I can show you something here. The other thing I'm going to do is look at this laser arrangement. And what I have here is I have an apparatus mounted to the frame that consists of a post coming up, giving me spacing between the center of my vessel and the outer edge of my vessel. So I could actually do, it looks like about 30-inch diameter vessels with this system. This could be shorter. If it's shorter, it's going to be stiffer. But this is how the system comes. There's a T here that set screws on, and I think we can get a good look at that. It's a kind of a good look at it. The T has a couple of set screws that attach to the vertical arm and the horizontal arm. The horizontal arm now has, I have both a laser and a camera on here. I really prefer to use the camera for finishing, but it's actually pretty fast to use the laser for roughing out. Oh, and Duncan, never be sorry about asking questions. Please ask all of them. Do I have a recommendation for removing the shavings? Oh boy, do I ever. It's a genius. David Nittman came up with it. It's called the spoon. I didn't bring it over here because I'm not actually doing any hollowing. I'll use it in my demo on Saturday, but I can run over and get it for you, and maybe a little bit of an explanation of how I use it as well. Okay, the spoon. It's just a formed scooper, and a lot of people will use a device like this, and they'll just go scoop. They'll turn the lathe off, and they'll scoop, scoop, scoop. Boring. The way to use this is turn the lathe, leave the lathe running, and put the scoop in, and it deflects a stream of shavings out the opening. And it won't probably get all of them, not on a form like this, but that saves a lot of time. The other way to get the chips out that I will often use is just compressed air blowing in the hole, and that gets rid of the chips, but it also puts dust in the air, so that's not the best way. Okay, so where was I? I'm talking about setting up this laser and camera. And I'm not going to use either one. Actually, the camera is not hooked up. It's just got its wire here. I'm going to work on that later. But I want to show you just, we'll use the laser as an example here. So I have this horizontal bar that can be adjusted with these set screws in and out. First thing I'm going to do is rotate this bar. I guess I don't need to. No, I don't need to rotate the bar. I'll rotate this little, see if we can get a better picture of this. This little holder that holds the laser, and I'm using the same one to hold the camera here. Let's take this off. This has got the camera on it, but it goes on the bar, and tighten it up, and it tightens on the bar. It can rotate on the bar, but it can't swivel this way. And I'm going to set it up so I don't need to swivel it. A modified back scratcher, that's pretty funny. Yeah, very good, very good. Yep, same idea. David made that one, pounded it out of aluminum. So what I'm going to do to set the vertical or the horizontal bar is I'm going to take my laser thing and put it plumb, straight up and down vertical. See it over here, maybe over here. This one is distorted. It's not showing you reality here. This shows you that it's, let me look at it, pretty well straight up and down. And this is not rocket science here, just more or less get it there. And then I will turn on the laser. First, let me show you turning on the laser. There's a little rubber ring. It's called a castration ring, I think. Don't ask me to explain that one. It gets rolled up so that it covers up the laser's push button switch so that the switch will stay on. These laser pointers are designed to have to hold the button down to keep the laser on. Now, I see a little dot. From the laser. I want that dot to be close to my cutter. So I have set my laser holder where I want it along the bar. I want it X amount of distance from the end of the bar. I don't want this bar to just stick out really long, because the more sticking out of the T, the more vibration I'm likely to have. So I would like to shorten this whole arrangement up as much as possible. So I've put the laser holder where I want it. Now I'm going to move this piece of tubing in its T until I get the laser dot close to the cutter. And I'm actually going to just put it, this amount of adjustment gets tweaked a lot in use by manipulating the laser holder, not by doing these set screws. At this point now, I'm going to tighten up those screws, and if you'll notice, the pin that goes through the end of the D handle to keep the D handle from being able to be pulled out of the window accidentally happens to be the Allen wrench that tightens up where the bars come out. So for changing bars, I'm using the Allen wrench that's right there all the time. And I'm also going to use it to tighten up these screws so that that top horizontal tube that holds the laser will stay put. And now I'm ready basically to set the laser for the work I'm going to do. And that's going to, I guess, depend on what kind of work I actually do. Move us up here. I don't really need to. I have a bunch of slides showing how I set the laser as well. We're getting way over time, and I think I can show this with the slides actually faster than I can talk about it. So what I want to do is put the laser wall thickness away. I guess we'll use this here. I don't know how he does it. I don't actually do this. I use my ruler like that, but Lyle uses this little card here, and he uses it. A good example of what this card is showing me here is that let's say I'm going to be hollowing this area of the vessel, and the tool, the hollowing rig is going to be in about this attitude. And I've adjusted my swivel assembly, which it's called that because it swivels. I can loosen this nut and swivel this cutter around wherever I want it. Now I want the cutter to be 90 degrees to the wall so that when I measure my wall thickness and I set my laser, I'm setting it so that the distance from the laser to the cutter, equals my wall thickness. Let's see if you can see it better here. So you see that, there it is. So the distance between the laser dot and the cutter equals my intended wall thickness. I can, if I want to know what my intended wall thickness is, which I always do, I'll use this ruler and it'll tell me, oh, 3/16. That sounds good. So now I will tighten up this laser holder. And here's something to mention. The laser kind of wants to be directly above the cutter. And you'll hear people say, oh, it's got to be a perfect vertical right above the cutter, or you won't get an accurate wall thickness measurement. And that is fundamentally true. But in reality, here's what happens. When you care about your measurement, it's when you are looking for a wall thickness this small. The distance, the amount that you will be inaccurate if your laser line is off a little bit, when your wall thickness is this thin, is so little, you don't need to worry about it. Yeah, okay, it's less accurate when you're roughing and your walls are really thick and at that point, you don't really care that much. And So here's what I want to say about the laser. And this is why I actually prefer the camera, because the camera does not have the same, it doesn't measure quite the same way. You actually have a picture of the cutter superimposed on your vessel while you're turning. Whereas the laser, as soon as I put the tool inside the vessel, which you can't see here, I am going to have to change my, you can see that there's a laser dot on there. Um, Once I have the tool inside the piece, I can't see the tool anymore. Can't see it there. See it here. Okay, you can see it here. And so my laser dot right in this area of the vessel is showing me once the laser dot, we call it, falls off the edge of the piece, once you can no longer see it, then you are at your wall thickness. Here's an explanation of what's going on here. Here's what I just did. I set my laser dot to be wall thickness away from the cutter so that where the cutter is contacting the wall, 90 degrees to the point of cut, there's the laser dot. It only gives me my accurate wall thickness if it's measuring 90 degrees to the wall at that point. So to do this upper part of the vessel, this works great. Now when I do this, the more parallel to the lathe bed area, the largest diameter of the piece, I have reset. You see, I reset where my laser dot is. The laser dot is now 90 degrees to the wall at the point of contact. In this picture, the point of contact is in a different place. So now I'm going to get an accurate wall thickness right here on the vessel, but only right here. If I try to measure the wall thickness at the large diameter with my laser set here, I don't get an accurate wall thickness measurement. I have to be measuring 90 degrees to the point of contact with the laser to get it to do an accurate measurement. So here's how I'd set a laser up for a shape like this. I've got this laser setting, which will do the area of the vessel in the green box. Then I'm going to reset the laser to do this part of the vessel. And then I'm going to reset the laser again to do this lower part. And then I'll reset it again. I don't know if I show that here. Yeah. And what this is telling me is I need to reset the laser again because I can't even get to the bottom with the swivel assembly the way it is here. I wonder if I swiveled it again. I didn't. So I'm going to need to swivel that swivel assembly again and reset the laser so that the cutter is cutting right at the bottom of the vessel, whereas it can't reach the bottom of the vessel right now. So this apparatus being very much in the way, I'm going to take it off. And here's what I just did here. When I take this off, I pulled the pin out, and I'm going to drop the pin right through there. So that pin is always with me, and this is not too heavy. And I just find a place to put it down. Right now, I'm just putting it down in front of me. And don't forget to turn the laser off or you'll kill your batteries. And you can use rechargeable batteries in that. So I'm not going to talk about the camera today. I will do that in another live stream. I'll talk about it a little bit in Saturday's demo. So thank you. I'm glad that made sense. Yeah, I prefer the camera because the camera does not need to be reset as frequently for the shape of the vessel. Now, it depends what shape vessel you're doing. Some vessel shapes, you can do most of it with one laser setting. And when I'm roughing out, I don't even set a wall thickness. I put the laser dot on the very end of the cutter, and I just guess at my wall thickness because I'm roughing out. The walls are going to be thick anyway. So that's why I like to use a laser for roughing, because it's a little bit less to set up, but I don't need the accuracy. And when I'm doing my final wall thickness and I want to know where the bumps are inside the vessel and I want to actually see where the tool is, then I use the camera. So more on that later. And mounting the teardrop to the Jamieson bar. I could talk about that, assuming my video cameras will let me get a view into there. We're going to see, okay, we see this, and it's a swivel assembly. It's just a little bit of background for us. To put the teardrop on, do I have one here? Darn, I don't think I have one. Anyway, the teardrop goes on under the same screw that the swivel assembly goes under. If you're familiar with that teardrop, you would know that it has a slot just like the swivel assembly has. So I will just put it underneath this same bolt. Why am I using a bolt instead of an Allen screw? Um, they the first time I got one of these was on the Dennis Stewart system, and it used an identical swivel assembly, and they came with a teardrop also. But they had an Allen screw to do to put the cutter on. Well, that Allen head fills up with chips like nobody's business, and it was a real nightmare to deal with. A nut driver and a hex head bolt, perfect. So there we are. I'm going to just put my swivel back on there so I don't lose it. And we'll take this out so it doesn't cover my face. And I will say good evening to you all, and thank you for being here. It's been fun. I hope you enjoyed this rundown of the mechanics and physics of hollowing systems. It's a subject that I think is important because we've got all these hollowing systems and we don't know where to start, which one to choose, why one might be better than another, or maybe why they are not any better. So thank you all for being here. Michael, thanks for coming to see me. And whoever Mux is, thank you for being here. John, good to have you all here. And I will say goodnight and see some of you on Saturday. Shall I put up the QR code again? Yeah, let's try it. Let's see if I can. Here it is. There's a QR code. Scan that code and you get a discount on Saturday's demo. And if you don't get to it in time for the demo, then you'll get the video, the recording of the demo. So on that cheerful note, I will see y'all later. Over and out.